everyone. I'd like to go and take a look at more trig word problems practice. This is scatter plots and word problems assignment 50, and see if we can go through all the problems on this this worksheet before you take your test. The first problem is pretty straightforward. The tallest TV transmitting tower in the United States is in North Dakota. If you stand a mile back from the tower, 5,280 feet is 1 mile, then you'll notice that you have to look up with an angle of 21.3 degrees. That's our angle of elevation. And we're asked to find out how tall the tower is. So this looks like a fairly straightforward right triangle problem. We're looking for opposite, we're given adjacent, and we're given this angle of elevation. So I'm going to say tangent of 21.3 degrees equals t over 5,280. And if I multiply both sides by 5,280, I'll be able to find out what t is. I'll pull out my calculator. Make sure that your calculator's mode is set on degrees. You want degrees for this problem. 5280 tangent 21.3, and we get 2058.586 feet tall. Alright, almost half a mile tall. It's a pretty big TV tower. There's problem number 1. Let's take problem number 2. Problem number 2 says, Statue of Liberty is approximately 305 feet tall. Standing in the crown, you look down the angle of depression from the top of the tower. That's our angle of depression from the top of the tower, is 23.7 degrees. You see a ship in the harbor. How far from the base of the tower is the ship? Well, remember that the angle of depression and the angle of elevation are the same. And again, we've got opposite. We're looking for adjacent. I think this is an opportunity for tangent. 23.7 degrees equals 305 over x. So if I multiply both sides by x in this problem, I get x tan 23.7 equals 305, but I want to get x by itself, so I'm going to need to divide here by tangent 23.7 degrees. Divide by tangent 23.7 degrees. So 305 divided by tangent 23.7 would be what x is. So 305 divided by tangent 23.7, and I end up with 694.809 feet. That's how far the ship is from the base of the tower. Okay, there's problem number 2. Problem number 3. Find the area of a regular hexagon. Remember, a hexagon, the number of sides is 6. And if we're looking for the area of a regular hexagon whose side length is 10, remember, for regular polygons, we use area equals 1/2 perimeter times apothem. So here's my apothem. This is my side length. We know the side length is 10. So this is split into 2 equal pieces by our apothem. So this must be 5, and this must be 5. Alright, now I need to find the apothem. I've got one side length, and I need to find this. I don't know this, so I'm not going to be able to use Pythagorean theorem. I'm going to have to know an angle in order to do this problem. Luckily, in class, we talked about a formula for finding theta. We said that theta was equal to n minus 2 times 180 divided by 2n. This finds out how big theta is. So let's see what that would be for a hexagon. N is 6 for a hexagon. So theta equals 6 minus 2 times 180 over 2 times 6. Well, I can do some canceling here and some simplifying. 4 times 180 over 2 times 6. 2 goes into 4 twice. 6 goes into 180 30 times. 2 times 30. I get that theta equals 60 degrees. So this theta is 60 degrees. So if I think about tangent 60 equals apothem over 5, I know that the apothem is 5 tangent 60. We know the tangent of 60 from our unit circle. It's root 3 over 2 divided by 1/2, or root 3. So we get 5 root 3 is our apothem. We could also figure this out on our calculator and decimalize it. And that wouldn't be a bad idea, because I'm about to say that the area is 1/2 perimeter. Well, we've got 6 sides, and each of those 6 sides is 10. So perimeter, 6 times 10, perimeter would be 60. So 1/2 perimeter times apothem, which gives me 150 root 3. And if I pull out my calculator, 150 square root of 3 is 259.808 square, and these were side lengths, so I don't know if these are inches, feet, or meters. There's my area. We had to use area equals 1/2 perimeter times apothem, and we had to use this formula to figure out theta so that we could figure out the apothem. The apothem required us to find that angle. Okay? Let's practice that process again with problem number 4. Problem number 4 says the area of a regular octagon whose side length, so n equals 8, and the side length in this problem is 20. Okay, again, we need to use area equals 1/2 perimeter times apothem. Again, I'm thinking about an octagon here, something with 8 sides. I'm only drawing part of this shape. Theta, apothem. If the whole side is 20, then each of these is 10. And again, I need to find theta in order to find the apothem. So what was that formula? N minus 2 times 180 all over 2n. So with our n being equal to 8, we have 8 minus 2 times 180 over 2 times 8. Or 6 times 180 all over 2 times 8. Well, I can do some simplifying here. I know that 4 goes into this twice, and 4 goes into this 45 times. I know that 2 goes into this 3 times, and 2 goes into this once. So I get 3 times 45 over 2, or theta equals 67.5 degrees. Did that get on there? Not quite. Okay, 67.5. Theta equals 67.5 degrees. So now when I build this equation for this right triangle using tangent, I would say tangent of 67.5 degrees equals apothem over 10. And so the apothem in this problem is 10 tan 67.5. No hesitation on my part. I'm going to need my calculator soon. But I will say that area equals 1/2 perimeter. The side lengths are 20, and we've got 8 sides, so 20 times 8 for the perimeter. So the perimeter is 160, and therefore our area, 1/2 perimeter, times apothem, 10 tan 67.5. On my calculator, 1/2 times 160 times 10, tangent 67.5, and I get the area is 193.137. Okay, so that's number 4. Let's take a look at 5. 5 is also an area of a polygon problem, but this time we're taking our polygon and we're putting it inside a circle. And when we put this shape inside a circle, we're given the radius. In this problem, the radius of the circle is 10. Notice we need to find the apothem, but we also need to find x because we know that 2x will be a side length. And we're going to have to know the side length because side length times the number of sides will give us the perimeter. We need both of these pieces of information in order to figure out the area of this regular hexagon. So radius of 10, because we need that theta again. What was that formula? Theta equals n minus 2 times 180 all over 2n. And for a hexagon, we said that n was 6 sides. So theta equals 6 minus 2, 180 over 2 times 6. And when I simplify here, I get 60 degrees. So theta is 60. Okay? 60 degrees. This is 10. This is the apothem. And this is x. So let's build an equation to help us find apothem. Apothem is opposite. 10 is the hypotenuse. Therefore, sine of 60 equals apothem over 10. Or apothem equals 10 sine 60. Well, I know the sine of 60 from our work with the unit circle. We know that's root 3 over 2 times 10. And so 5 root 3 is the apothem. Okay, I've got 5 root 3 for the apothem. Now what about x? What trig equation could I use there? Well, I could use tangent with these two, but I would rather use cosine because if I made a mistake here, that's going to guarantee that this is wrong now. Instead, I'm going to use cosine of 60 equals adjacent over hypotenuse. So 10 cosine 60 equals x. Cosine of 60 is 1/2 times 10 is 5. So x is 5. What does that tell us about the whole side length? The side length is going to be 2 times x, or 10. And therefore the perimeter, well, we know that the sides are 10, and there are 6 of them. So we've got 60. Okay, so area is what we're looking for here. Area equals 1/2 perimeter times apothem, which will be 1/2 60 times our apothem was 5 root 3. And so I get 150 root 3. Or, since we did this problem already, 259.808. Okie doke. And that was problem 5. Let's take a look at problem 6. 6 says the area of a regular octagon inscribed in a circle with a radius of 20. So now we're saying that the radius is 20. We need the apothem, we need x, and what about this angle? Well, for an octagon, we have 8 minus 2 times 180 over 8 times 2. And we already did this computation. We found 67.5 degrees. So, if I build this right triangle with 67.5 degrees, apothem, x, and 20, how can I find apothem? Well, apothem is going to be opposite over hypotenuse for this angle, and so sine of 67.5 degrees equals apothem over 20, or apothem equals 20 sine 67.5. Likewise, to find x, I'm still going to use cosine of that angle, x over 20. And so x is going to be 20 cosine 67.5. Remember though, x is only half of the side length. It takes 2 x's to get a side length. So 40 cosine 67.5. And what about the perimeter? Well, the perimeter is the side length times the number of sides. And in an octagon, we have 8 of those sides. So the perimeter is going to be 8 times the side length. Cosine 67.5. There's our perimeter. Or 320 cosine 67.5. So I guess I could write the area as 1/2 the perimeter, 320 cosine 67.5, times the apothem, which was 20 sine 67.5. So I'll pull out my calculator. Let's compute this. 1/2 times 320 cosine 67.5. Don't forget to close that parenthesis. Times 20 sine 67.5. And I get 113.3708, which will round to 1. I feel like I left a number off there. Yes, I did. 1131.371 square units. Okay, that's number 6. Let's take a look at 7. A rotating Ferris wheel with a radius of 25 feet is revolving at 2 revolutions per minute. That's angular velocity, but it's not in radians per minute, is it? So let's multiply by 2 pi radians per revolution. So revolutions will cancel, and we'll get 4 pi radians per minute. So there's our angular velocity. How fast is the seat moving in feet per minute? Well, feet per minute is a linear velocity. And I remember we talked about a relationship between linear and angular velocity. We said linear velocity was angular velocity times radius. Remember, angular velocity we want in terms of radians per time unit. So I'm glad we made this conversion. We couldn't just use the 2. We need this 4 pi. 4 pi times 25. And so I get 100 pi, or 314.159. And what are the units here on this? Well, they're feet per minute, because minutes were our time unit and feet were the units on our radius. Okay, 100 pi feet per minute, or 314.159 feet per minute. Here's problem number 7. What about problem number 8? Problem number 8 is another linear and angular velocity problem. We're on a carousel, a merry-go-round now. The outer row of animals is 20 feet from the center. The inner row is 12 feet from the center. What is the difference in linear velocities in feet per minute if the carousel is turning at 2.5 revolutions per minute? Okay, so again, our angular velocity, 2.5, or 5/2 of a revolution per minute. We want radians per time unit, so we need to multiply by 2 pi radians per revolution. And we'll end up with 5 pi radians per minute. Alright, that's our angular velocity. And this is a spinning disk problem, so anywhere on the spinning disk has the same angular velocity. Here or here, the angular velocity is 5 pi. the linear velocity of the inner ring is going to be different from the linear velocity of the outer ring. The inner ring, remember our formula is V equals R times omega. Our inner velocity is going to be 5 pi times the radius of 12, or 60 feet per minute, as opposed to the outer ring, where things go much faster, still 5 pi for the angular, but now we have 20-foot radius, so we get, 100 pi feet per minute. Oops, that's better. Okay, you can certainly convert those. 60, oh, I want the difference in these. Well, the difference in these, 100 pi minus 60 pi is 40 pi. And on my calculator, 40 pi turns out to be 125.663 feet per minute. Okay? 4. So there's problem number 8. We're almost halfway done. Let's take a look at problem number 9. Problem number 9, approximately 14 hours of daylight in June and 10 hours of daylight in January in Los Angeles. If January is t equals 0, I really want to say t equals 1, but I'm going to go with t equals 0, and the amount of daylight is 10 hours. But in June, let's see, January is 0, February, March, April, May, June. So 0, 1, 2, 3, 4, 5. June, t equals 5. There's 6 months here, and that's 14 hours. Okay. Develop a model for daylight as a function of time in months from January. Use this to predict when there will be 13 hours of sunlight. Okay, so I know that these are my outputs, these are my hours of sunlight. So to find my D value, I average the low and the high. 10 plus 14 divided by 2, 24 divided by 2 is 12. Our amplitude is I, Y value minus D, or 14 minus 12, or 2. And in January, we start with our low. We start down here, and we go up to our high in June, and then back to our low again. So I think this is a negative cosine graph, -2 cosine. Now I need a B value. Well, the period is 1 year, or 12 months, so 2 pi over 12. And I'm not shifting away from this. I'm starting at 0. This is 0, so I'm going to go with x minus 0 plus our D value of 12. So here's hours of sunlight, daylight. So let's go with sunlight. Sunlight as a function of x number of months. Okay, so that's building the model. And then it says, when is the first time there will be 13 hours of sunlight? So I want sunlight to equal 13. Cosine pi over 6x plus 12. And you could go about subtracting 12 from both sides and dividing by -2. And you'd have -1/2 equals cosine pi over 6x. And we know cosine is equal to -1/2 at, well, the first time that happens is at 2 pi over 3. So I know that pi over 6x should equal 2 pi over 3. So if I multiply by 6 over pi on both sides, I end up with x equals 4. So 5 was June, this must be May. Okay, but You could also think about graphing this way. Remember though, for graphing problems, you want to switch the mode over to radians. I'm going to graph the line y equals 13, and I'm going to graph our trig function -2 cosine pi divided by 6, x minus 0, plus 12. I want a viewing window that can see this y equals 13 number. And my amplitude is 2, so I'm going between 11 to up. I'm going 14 to 10. So I'm going to change my window 0 to 1 year, and my y values go from 10 to 14. And I should see my graph fitting nicely in these parameters. I'm double checking to make sure I'm in radians, and I'll hit graph. Uh-oh, it graphs a straight line. Oh, that's y equals 13. Look, here it is. Let's do second, calculate, intersect. If I bring my calculator close to that point of intersection and hit enter 3 times, I get x equal to 4, just like we did when we solved it algebraically. So I've got 2 ways to solve this after I build the model. I have to build this hours of sunlight model and then set that model equal to 13 either algebraically or graphically by graphing both of those and seeing where they intersect. Okay? There's problem 9. Let's take a look at problem 10. 10 says you stand 400 feet back from a cliff. 400 feet. There's a cliff. You look up with an angle of elevation of 28 degrees. 28 degrees. And you see a ledge. You look up at an angle of elevation of 40 degrees. And you see a rescue party at the top. And we want to know how far apart are the 2 groups. We want to know this. Well, I don't know that either, and I think that's going to be important, because just like when we did that first Mount Lemmon problem, we need to split this up into 2 right triangles and write a trig equation for each one. It looks like we're looking for opposite and we have adjacent, so tangent 28 equals y over 400. So y is going to be 400 tan 28. Well, that's great. That tells me how long this distance is. I could even pull out my calculator. Uh-oh, these are in degrees. I better change my mode back to degrees. Don't forget to do this on the test. 400 tan 28. So I get 212.6837727 feet. Okay, but I still need to find this. Well, I can write another trig equation here. Tangent of 40 equals x plus y over 400. So 400 tan 40 equals x plus y. But look, we just found y. So I know that 400 tan 40 minus y minus 400 tan 28 will tell me what x is. Well, let's see what that is. 400 tan 40, close that parenthesis, minus 400, 400 tan 40 minus 400 tan 28. So we get that the distance between these 2 groups is 122.956 feet. That's what x equals. Okay, that's problem number 10. Huh. I got a different answer before. Let me just check my work. 28 degrees, 40 degrees, 40 is x plus y, 410.28. Yes, that's that number. And then 410.40 minus 212.683.7727. And I get this number again. I better change that. Okay, 122.956. Okay, problem 11. Ooh, a picture of an acacia tree. So, let's see. You're standing 400 feet behind your friend, Mr. Giraffe. And looking up at the top, you see the top of the giant acacia tree with an angle of 20 degrees. There's the giraffe. There's you. Here's the tree. You look up. You're standing 400 feet behind Mr. Giraffe. 20 degrees for you to see the top of the tree. 40 degrees for the giraffe to see the top of the tree. How tall is the tree? Well, we don't know this distance, but we're going to need it because, again, I have to split this up into two right triangles. One right triangle with t, x, and 40. And this other big right triangle with t, x plus 400, and 20 degrees. So if we write a tangent equation for each, tangent 40 equals t over x, or t equals x tan 40. I can also solve this equation, or write this equation and then solve it for t. Tan 20 equals t over x plus 400. So x plus 400 parentheses tan 20 equals t. Remember, you have to distribute here. But this big T and this big T are the same big T. So I can set this stuff equal to this stuff. So let's do that now. And distribute. And so then we're going to have x tan 40 equals x tan 20 plus 400 tan 20. Okay, get all the x stuff on one side by subtracting x tan 20 from both sides. No, x tan 40 minus x tan 20 is not x tan 20. Don't do that. Instead, we get to write x tan 40 minus x tan 20 equals 400 tan 20. I do notice that each of these terms has an x in them, so I can factor an x out, leaving me with tan 40 minus tan 20. Again, that is not tan 20. Don't fall for that. Instead, what I want to say is, hey, I'm trying to solve for x. All this stuff is attached to x with multiplication. So I'm going to need to divide both sides by this stuff to get x alone. So x will be equal to 400 tan 20 over tan 40 minus tan 20. Okay, let's see what we get. Remember, everything in the numerator in parentheses divided by tan 40 close parentheses minus tan 20 close parentheses and close parentheses for the denominator. And I get that x equals 306.417777772. Is that our solution? No, that's what x is. We're looking for how tall the tree is. Well, remember we had this little equation over here that tree was equal to x tan 40. So there's my x. If I do 306.4177777, I think it's only 5 sevens. 1, 2, 3, no, it's 4 sevens. 1, 2, 3, 4, and a 2. 1, 2, 3, 4, and 2, 10, 40. We can find the height of the tree times 10, 40 as 257.115 feet. 257.115 feet is the height of the tree. Okay, look, we had to split this up into two triangles, write a trig equation for both, and then we used substitution to solve that system. All right, 12. You're standing on the top of a 300-foot lighthouse. You looked down. This is the lighthouse. Look down with the angle of depression of 64 degrees. And you see a small boat. When you look down with an angle of depression of 34 degrees, that's less than 64, 34 degrees, you see shark, hungry shark. How far is the shark away from those boats? So I want to find this distance. I don't know this. I do know that the lighthouse is 300 feet tall. So remember that angle of depression is the same as the angle of elevation. And so I have this right triangle, x, 64, 300. And I've also got this big right triangle, x plus d, 300. And remember, the angle of depression and the angle of elevation are the same. So this is 34 degrees here. Okay, write some trig equations. 10, 64 equals 300 over x. X equals 300 over 10, 64. Here, tangent 34 equals 300 over x plus d. I get x plus d is 300 over 10, 34. We know what x is. It's 300 over 10, 64. So we could write 300 over 10, 64 plus d equals 300 over 10, 34. So to get d by itself, I'm going to need to subtract 300, 10, 64 from both sides. Okay, so d equals 300, 10, 34 minus 300, 10, 64. We'll figure that out with our calculator. 300, 10, 34. No, 300 divided by 10, 34. Minus 300 divided by 10, 64. Notice I'm closing the parentheses on each of those trig functions, and I get that the distance between them is 298.449 feet. Okay, row fast, little boat. Watch out for that hungry shark. Okay, usually sharks leave humans alone. It's a big shark week myth. 13. You were on the beach at Port Aransas, Texas at 2 p.m. on March 19th. The tide is in, the water is deepest. At this point, you find the depth of water at the end of the pier to be 1.5 meters. Okay, so at 2 p.m., 1.5 meters. And at 8 p.m., 6 hours later, you have low tide, 1.1 meters. So we could say the tide, 2 p.m., is 1.1 5 meters, and 8 p.m. is 1.1 meters. And then, how many hours was that? That was 6 hours. 6 hours after 8 p.m. will be 2 a.m., and we'll have another 1.5 meters. I find, though, that when I get to 2 a.m., I want to keep counting past 12, so I'm going to write 2, 8, 14, 1.5. Okay. All right, so assume that the depth of the water varies sinusoidally with time. That's what we've got here. And we want to say, derive an expression, depth of the water in terms of number of hours since March 19th. Great. So we're going to say D equals the average of the high and low y values. 2.6 over 2 is 1.3. We know that A is equal to the high y value minus D. So 1.5 minus 1.3, 4.2. We know that B is 2 pi over the period, and the period is the distance from 2 p.m. to 2 a.m., or 12 hours. So we get pi over 6 for our B value. And our C is our horizontal shift from where we expect. Well, I expect the high point on cosine to happen at 0. And here this is happening at 2. So I think my C value is 2. Okay, so let's write this model. Y equals 0.2 cosine pi over 6 x minus 2, close 2 parentheses, plus 1.3. There's our depth of water as a function of time. Use the model to predict the depth of water at 4 p.m. on the 19th. So this was 2 p.m. We want 4 p.m. And, there was an and there, 5 p.m. on the 20th. 5 p.m. on the 20th. Well, let's think about this. 2 p.m. on the 19th to 2 p.m. on the 20th will be 24 hours later. But we don't want 2 p.m. on the 20th. We want 5 p.m. on the 20th. That's 3 hours after this, so I want to plug in a 29. I want to plug a 4 into here to find the depth at 4 p.m. on the 19th, and I want to plug a 29 in here to find the depth on the at 5 p.m. on the 20th. And I'm going to do this with my calculator's table feature. That'll be a lot faster. Make sure your mode is in radians because you're graphing a trig function. So we're typing in 0.2 cosine pi divided by 6 x minus 2, close 2 parentheses, plus 1.3. We don't need that anymore. And we'll go over to the table, and we'll type in 4, and we'll see that the depth is 1.4 meters at 4 p.m., and we'll type in that 29. 29, 3 hours after 26, 24 after, yes, 29, and I got 1.3 meters. So for part B, at 4 p.m. on 3/19, the depth is 1.4 meters, and at 5 p.m. on 3/20, the depth is 1.3 meters. Okay, what about part C? Part C, it says, what time will the first low tide occur on 3/20? Well, 3/20 occurs here at 12. So I'm looking after 12, I want my first low tide. Well, if I take a look at this graph, and I'm going to reset my viewing window, right, because my y values now go from 1.1 to 1.5, 1.1 to 1.5. I want my time to go at least 24 hours in steps of 6-hour increments, and graph. So there's what looks like my first low tide, but I wonder if that's on the 19th. See, I think that's the one at 8 p.m. So, second, calculate minimum. Let's confirm that. Look, see? Yep, that low is about 8 p.m. That's still on the 19th. We want the first low tide on the 20th, so we have to come over to this one here. I guess we could have found that one and then done, taken that time value and added 12 hours to it to get this one. But I'm going to say this is my left bound for the minimum. This is my right bound for the minimum. I do not want to guess, so I hit enter, and I get 19.9999 hours, or approximately 20 hours. So if 2 is 2 p.m. and 12 is midnight, this is 8 hours after midnight, or 8 a.m. on 3/20. We have low tide. That's part C. Part D, what's the earliest time on the 20th? The water will be 1.27 meters. Well, let's just graph 1.27. 1.27. And when did we say the 20th started? At 12, right? Well, let's reset our viewing window to start at 12. Graph. So we want to know the first time we intersect 1.27. So here's our time. Oh, there it is. That one, not that one. First time. Second, calculate, intersect. Yes, this is the first curve. Yes, this is the second curve. No, I do not want to guess. And D equals 17.288 hours. Okay. 12 is midnight, so this is 5.288 a.m. And what time is that? Well, 5 a.m. and then point 0.288 times 60 minutes in that hour. I get 5:17 a.m. And there's part D. Okay, that was 13. That took a while. Let's take a look at 14. Looks like another similar sort of problem. Suppose one day a flash mob of all 200 million adults climb on top of tables at t equals 0 and jump off. Resulting shock as we hit the Earth's surface will start the entire Earth vibrating in such a way that its surface first moves down from its normal position, first moves down, then moves up, overcomes, and back to its normal position. Oh, so we're building a negative sine graph. The period is 54 minutes, so we know 2 pi over 54, or pi over 27, is our B value. What else? We say we're going down 50. Is it feet or meters? 50 meters. 50 down and 50 up. And so our amplitude is 50. Sine starts at 0 on the midline, and this is starting on the midline of 0. So D equals 0 and C equals 0. And so our model then is going to be y equals negative 50 sine pi over 27x. There's our model. So let's see if we can answer some questions. At what time will the first maximum greatest distance above normal position occur? Well, if this is 0 and this is 54, halfway would be 27. And it looks like our first max occurs halfway between 27 and 54. So let's average those. 54 plus 27 over 2 is 81 over 2, or 40.5 minutes. At 40.5 minutes, we have our first maximum position. B, write an equation. Here's B. C, predict displacement at t equal to 21. Ooh, I guess I was supposed to write this as a function of time. So I want to plug a 21 in here. And I guess I could plug a 21 in there. But when I cut those 3's out, I'm going to have 7 over 9. And I don't know pi of 7 pi over 9. So I better just pull out my calculator and do negative 50. In fact, let's type it in. Negative 50 sine pi divided by 27. And we want an x in here too. And I want to plug a 21 in. And so I get y of 21 equals negative 32.139. Good. Feet. Meters. So we're still going down then. D, what are the first 3 times at which displacement is negative 37? So I want to get a graph of this, and we're going down 50 and up 50. That tells me my y value should be negative 50 to positive 50. I'll go in steps of 10. And what about time? Well, I'm going from 0 to 54. And steps of 6 works there. Graph. Scale. X scale 6. Graph. Okay. There's our negative sine graph. And we need to graph the line negative 37 as well. Not there, but in y2. Hit graph. So not only are we going to get our function of time, but we're also going to get this horizontal line at negative 37. But look, I see the first 2 times. I don't see the third time. I need to find 3 times, so I'm going to have to add some more time to this. So let's change this viewing window. Instead of stopping with 1 period, why don't we go 2 periods? 108 in steps of 12. And we're looking for the first 1, 2, 3 points of intersection. So I'm just going to do second, calculate, intersect. I'm going to bring my calculator cursor to the left side of that point of intersection. Hit enter, hit enter, hit enter. And I get that the first time is 7.1597 or 7.160. Now that's 7 minutes, 0.16. Well, so 0.16 times 60 gives me, 0.16 times 60 gives me 9.6. So 7 minutes, 9.6 seconds. There's the first time. And now I want to repeat that process 2 more times. When you do, you should get t equals 19.840 and t equals 61.159 minutes for the second and third options. Okay? All right, that's the last of those. Ooh, sunrise in Tucson. Why, look, another opportunity to do a scatterplot problem. It's really a scatterplot problem. Wow, we've got to type this data in. Okay, so the period. Well, this is 1 year, and again, I'm going to say the period had better be 12 months. Oh, I just need the period, not the b value. Period equals 12 months. Okay, find b. Well, we know 2 pi over the period is our b value. So 2 pi over 12 or pi over 6 is what I expect. Sinusoidal axis. Well, sinusoidal axis is usually the average of our high and low y values. It looks like my high y value is 7.4 and my low y value is 5.283 divided by 2. So 7.4 plus 5.283 divided by 2 I get the d value should be 6.3415. Good. And write a tweaked model for sunrise as a function of time. Okay, so I got to type this data in. Stat is the button I press to get here. Edit, L1. All of these are months, so January 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12, and we actually go a 13th month. Okay, and then what about our sunrise times? 7.4, 7.283, 6.883, no, 833, 6.183, 5.617, 5.283, 5.333, 5.633, 5.967, 6.283, 6.6, 7.1, and finally 7.4. Okay, so we've got all our data in. Remember, when you want to do a scatter plot, you have to turn your plots on. Turn plot on. We also want to do zoom stat. And we see that graph. Well, let's plug in our model now. We've got a b value. We've got a d value. What about a? We know that a should be the I, y, minus d. So 7.4 minus 6.3415. 7.4 minus 6.3415. And I get 1.0585 as our a value. And c, well, c is where we're starting, and we're starting at 1, so c equals 1. So my model then is going to be positive cosine, y equals 1.0585 cosine pi over 6 x minus 1 plus 6.3415. So I'm going to type this in and see how well it fits. 1.0585 cosine pi divided by 6 x minus 1 plus 6.3415. And graph. Oh. Kind of looks like no tweaking necessary. Look, we hit the highs. We hit that low. Is that? I thought that was the low. No, 5.283 is the low. But the low doesn't happen exactly halfway across. That's why it's there. But we do get down to that low value. I'm kind of tempted to push the graph sideways a little bit. However, I'm reluctant to do that. I think instead that I'm more likely to want to stretch the graph open a little bit to see if I can pull down closer to these and get closer to those. So let's try tweaking our b value a little bit. Instead of pi over 6, how about 6.1? Graph. Well, that might be good, but I feel like now I'm too far to the right. I feel like I want to shift back to the left. So what if I bring this back a little bit? How about second insert 0.1? Oh, I don't like that at all. Well, yeah, no, I liked our original one more. Hmm. Yeah. Let's go back to delete. Just want to tap it left a hair. How about 0.9? Well, that feels a little closer. Now, is that better than the original? Well, let's type the original in. 1.0585 cosine pi divided by 6 x minus 1 plus 6.3415. Okay, so there's our tweaked graph. Here's our original. Yeah, well, I don't see much difference between those two graphs. So I think I could just go with my original graph, this one, for my model. If you're planning a romantic Valentine's Day surprise for your special person, you need to predict sunrise on 2/14. Well, 2/14 is halfway across the month. Ooh, and on 2019. So remember, our data starts at 1. This is 12, 13, 14, and we want halfway across the month. So I want time equals 14.5. So if I go over to the table and type in 14.5, I get 7.09. So 0.09 times 60, that's 7:05 a.m. Okay, and then find two dates in 2018 when the sunrise will be 5:35 a.m. So these output times were 5:35, 5:35, which is 5 plus 35 over 60. So 5 plus 35 divided by 60 gives me 5.58333. That's the y value I'm looking for, so let's graph that. 5.58333. Delete all this other stuff. Graph. And I'm looking for the first two dates when the sunrise will be this. Second, calculate, intersect, bring my cursor close to the point of intersection, enter, 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 and I get 5.525, and second, calculate, intersect, close to the other point of intersection, enter, 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 and I get 8.475. Okay, well, we know that 5 is May, but what date in May? 30 days have September, April, June, and November. All the rest have 31, so 0.525 times 31 equals 16th. So we want May 16th. And when else? 0.8 would be August. 30 days have September, April, June, and November. All the rest have 31. So 0.475 times 31, and I get August 14th. Okay, so that's what we're looking for in part F of number 15. 16. Okay, write the equation for each trig graph. This looks like a negative sine curve to me. And if it's a negative sine curve, I want to find these high and low points to help me find my d value and my a value. I've got 5 pi over 6, 12, and down here I have pi over 6, negative 8. So we know that d equals the average of the y's, and our a value is the high y minus d, or 12 minus 2, or 10. Big amplitude, little d. Okay, what else do we need? We need a b value. Remember that b is 2 pi over the period. The period is the ending x minus the starting x, 7 pi over 6, and over here we have negative pi over 6. How far is it from negative pi over 6 to 7 pi over 6? Well, from 0 to 7 pi over 6 is 7 pi over 6. From 0 to negative pi over 6 is another pi over 6. So the period is 8 pi over 6. So we get 2 pi over 8 pi over 6. Okay, so if I do the flip and multiply, I get 12 pi over 8 pi, or 3/2 for the b value. And finally, c is negative pi over 6, because that's where our graph is starting. So y equals negative 10 sine 3/2 x minus a minus pi over 6 plus 2. Okay, and then you're welcome to graph that and make sure it passes through these points. The easiest way to check is to set your viewing window so that it goes x min to x max, y min to y max, and see that it fits right inside. What about problem 17? 17, we've got a low point, a high point, and a low point. This is pi over 6, 1/2. This is 4 pi over 6, 3/2. And this is 7 pi over 6, 1/2. Again, our d value is the average of the high and low y values. That's a convenient d. Our a value, high y minus d, so 3/2 minus 1, or 1/2. Our b value is 2 pi over the period. The period goes from pi over 6 to 7 pi over 6. So what's that distance? 7 pi over 6 minus 1 pi over 6 is 6 pi over 6, or pi. So I get a b value of 2. And our c value is our starting x, pi over 6. So I would write the model, and we're starting low, going high, going low again. So I think this is a negative cosine. Y equals negative 1/2 cosine pi, parentheses, x minus pi over 6. Oops, this is a 2. Close 2 parentheses, plus 1. So negative 1/2 cosine 2 x minus pi over 6, close 2 parentheses, plus 1. Excellent. Okay, 2 problems left. Next one, number 18. We've got some limited information. It looks like a positive sine graph, but I don't feel like I have everything I need here. They don't give me the values of one full period. They only give me these x values for half a period. And this distance is half a period. That's pi over 2. Well, this must also be half a period. And so it's also pi over 2. So I know that one period is pi, and therefore my b value, 2 pi over period, is 2. I also know that this starting point, if I'm at pi over 2 and I go back pi over 2, would be 0. So I don't have any shift. What about d? Well, for d, I'm going to need some y values. Now, this is interesting. I have the midline, so I have my d value. And my a value is d minus low y, or 4 minus a minus 2. So I get amplitude of 6, because over here we have 3 pi over 4 negative 2. So then I put this all together and I say y equals 6 sine 2 plus 4. Now that's pretty straightforward. And then finally number 19. 19 has this high point and this low point. This is negative pi over 4, negative 1. And over here we have negative 3 pi over 4, and we have positive 7. So d value, 7 plus negative 1 divided by 2, 6 over 2, or 3. Our a value is the I y minus d, 7 minus 3, or 4. Now, there's my c value, negative 3 pi over 4. But what about our b value? Well, we need the period, and I don't have the full period. I've only got this distance, which is half a period. This is the distance from negative pi over 4 to negative 3 pi over 4, or from negative 3 pi over 4 to negative pi over 4. So negative pi over 4 minus a minus 3 pi over 4 is 2 pi over 4, or pi over 2. This distance is pi over 2, which means that this distance is pi over 2 also, which means one full period is pi. So again, we have 2 pi over pi, or 2 for our b value. So y equals positive cosine, 4 cosine, our b value 2, x minus negative 3 pi over 4, close two parentheses, plus a d value of 3. And of course, you could write that 2x plus 3 pi over 4 plus 3. You're welcome to distribute. I find that students who do that often make mistakes, so I don't do that. All right, there you go. That's problems 1 through 19. I hope that helps.